Um, Good afternoon, everyone. My name is Fodi Longman, and I'm from the Research, Technology and Innovation Division of the Nigerian National Petroleum Company Limited. Together with me, I have the head of innovation application and the head of service optimization as well. So part of the research we're doing is basically not entirely what I have seen a lot of you guys do here in terms of medical image analysis and all of that. We are doing what we call total organic carbon prediction because, as you know, Nigeria is an oil-producing country, and we are very much interested in hydrocarbon deposits. And we are looking into that using machine learning methods. So away from the conventional methods and introducing new methods. So this is exploratory in the sense that we've used the basic machine learning methods. And what we're trying to see is that if this will actually make a difference and take us away from the conventional methods. Apologies for that title in my presentation is quite big, but that's just what it is, okay? So just a little bit of my outline, just a background. And then the Kolmani oil field as well, our proposed framework, and then just results and discussion. Okay. So the Kolmani oil field is located in the, I think, northeast of Nigeria, somewhere along the Gongola Basin, as it's being called. It's estimated to have a reserve of about 1 billion barrels of crude oil, and then lies along that Gongola Basin in the upper Benue Trough. Drilling activities, 2 well-log data are in operation already. It's shown in the literature that well-log data are useful in determining source rock determination. So source rock is where hydrocarbon deposits are. As I said earlier, conventional methods are expensive. So if we have to take samples as when well logs are being done, it's expensive because we have to do the lab procedures, and that's less efficient, it's time consuming and resource consuming as well. So if there are ways that can take that away from us and save some cost, then that's why we're deploying the machine learning as well. So just a framework of our approach, quite a very simple approach. Exploratory data analysis, which a lot of data scientists waste a lot of their time on, EDA. So we want to see what is the correlation. Can we check for the normalcy of our data and all of that information? We don't want to bore our model with so much features, which is the columns. Well-log data come with a lot of columns and data, so we don't want to waste a lot of time. We want to take the most prominent features from that. Because we have some results that are being done with the classical method or the conventional method where TOC has already been predicted, we can actually label that and then try to do a supervised learning machine approach. And then we can classify, because it's not just enough to say this is the quantity of total organic carbon, but at every rate, TOC can be kind of classified according to the quality, okay? So at what point is the crude oil sweetest, as they call it? And then we can analyze the results as well. So the first EDA that we did was to check for correlation matrix. As I said earlier, previously, we have 2 well-log data done. So this is just for Kolmani 1 and then Kolmani 2. A lot of features on Kolmani 2 data, and it's very difficult to say where the correlation actually matters. And you might notice that there is little correlation among the variables. Now, depending on the company that has done the well-log data exploration and all of that, and getting that information relies on the amount of features that you can have. So in the literature, common features including gamma ray, neuron, p-sonic, and other have been established to be great features for total organic carbon. But if we are doing machine learning, we don't want to rely on what is always in the literature. Can machine learning actually point us to what features are better for us to do this kind of approach and deviate away from the conventional methods? The QQ plot here is just to show us the validity on the assumption of the normalcy of our data. As I said, with the correlation matrix, we don't actually see that normalcy. But even though you can say that the data is a little bit skewed, but that could be from data integrity and all of that information, depending on how that data is being collected. And that is one of the concerns that we do have. So that's just between measured TOC, which is using the conventional method, and some of those attribute or features that have featured more in literature. So like neutron and gamma ray. And very important, if you've, by any chance, you've come along you've come across change of log R or TOC prediction using certain methods, the change in log R is very common. So what we did, we deployed certain methods of machine learning, including random forest, gradient boosting, which the previous speaker has spoken about, linear regression to extract features from the data. And we can see, depending on the kind of method, but the change in log R is actually very prominent with this. So that's for Kolmani log 2 data. And then we did the same for Kolmani 3 data as well, where we have more features. And then we use ensemble methods to do some kind of regression analysis. And what is evident here is that, of course, it's performing well to an acceptable level. We can see the MSE values, RMSE values, and all of that values. What is very prominent is that the higher the features that we do have, the better the result. And this is why we can see from the right corner of the result. So this is Kolmani 2, where we have less features from the correlation matrix, if you remember, and this is where we have more of that data. Again, very important, we try to look at classification of different methods. As I said earlier, it's not just enough to determine TOC, but what is the quality of the TOC that we predicted. So with ROC values, once it's shifted towards the left corner, the better the model is. And we calculated the AUC as well, so the area under curve as well. And then we compared about 5 methods to do this. What is surprising is that if we look at this could be from the integrity of the data, but surprisingly, naive-Bayes is not performing to expectation, and that's something that we plan to look in the future or come up with a custom algorithm for classification as well. So this is very exploratory analysis of different methods, not anything in particular. And then we did what we call the recursive feature elimination with cross validation, because we want to see how we eliminate those features that are not relevant. We are doing this because, as I said earlier, there have been some discrepancies in the data in terms of the features, and that will come from how that data is being collected. But what are those features that will feature more or remain kind of constant over time? With that data, we can see about 6 features here and then 10 features on the Kolmani 3 data. In the future, we want to do what I've seen someone show here, like create a data pipeline, in the sense that when this data comes, it goes through some more intense processing, and which will include feature elimination and feature extraction and all of that information as well. So that's just about our results. What we found out is that data integrity plays a major role. And I just want to use this opportunity to kind of introduce our organization to you, in case you find it quite interesting, and we can partner and collaborate in terms of research, development, and application as well. As I said earlier, I'm here with the head of innovation application. So maybe during the barbecue, you can have time and discuss in more detail if you find anything interesting. So our mandate, which is what I just want to clearly say here, is the research technology innovation is focused on innovative solutions, and then that will improve frontline delivery, back office operations, or generate additional revenue. I've seen a lot of very interesting applications being presented here, and it just keeps me thinking, where can we actually kind of replicate this application in terms of providing solutions to our business? So our focus areas, innovation-led research, development and application, and on strategy, we're already partnering with University of Manchester Metropolitan University, where I was a research associate in terms of energy efficiency and decarbonization. If you find anywhere that fits into what you're doing, please feel free to have a discussion with us during the barbecue or somewhere else after this. Okay. In essence, we have, this is just our focus. We have the robotic process automation, renewable energy, 3D printing, IT capability, and lubricant additives. So this is just our focus for the year. Well, for some reason, I think this hasn't updated, but I've come to the end of my presentation. If you do have any questions, please feel free to ask. Thank you very much.
It's interesting you mentioned about cooperating with academia.
Yeah.
You could say a few words about how you normally establish partnerships with.
So in terms of partnerships, what we do is to identify the strength of the institution. For example, with Manchester Metropolitan University, they're doing a lot of research in terms of energy efficiency and decarbonization and renewables. So we identify with that. In some certain situations where the university sent us some proposal over what they are doing and we find it relevant to the kind of business that we do, then we can further discussions on that as well. Yes.
Might be able to pay in a partnership?
It depends on the kind of data that you want. But as a company, definitely we have data policies, and depending on that kind of data that we can partner with, and as long as that research kind of solve some of our business problems and provide solutions, then probably we can have a kind of confidentiality agreement in terms of data and share that data to come up with innovative researches, which is what we're interested in. Yeah.
About adding some explainability to your system, so explainable AI, for example, decisions making. So,
well, we've talked about that, but yes, of course, when you emerging technologies are quite new, especially when you come to the domain of where we operate. So we are more comfortable to kind of build that and come into explainable AI and other emerging technologies as they apply to our business. But of course, it's one area that we're looking very much into, especially now that the world is going global with artificial intelligence and machine learning, and that's why we're trying to deviate from the conventional methods of doing things, relying on the laboratories and see how we could compare the results we get from implementing these emerging technologies with what we used to have or what we used to be more comfortable with, which is the conventional methods. All right. Okay.